All right, today we're going to tackle a puzzle that has stumped physicists for a solid century, but we're going to look at it through a brand new lens. A pretty radical idea that, believe it or not, goes right back to the work of Albert Einstein himself. So let's just dive right in. I want to kick things off with a question that really gets to the heart of what we're talking about today. What if the fundamental theories we use to describe the universe, what if they aren't actually telling us the whole story? What if they're just shadows flickering on a cave wall and the real thing is something else entirely? Just keep that question in the back of your mind as we go. So, our story really begins with what you could call Einstein's unfinished puzzle. For pretty much 100 years now, physics has been living with this deep, nagging contradiction right at its very core. See, on one side, you've got general relativity. That's Einstein's masterpiece, right? It describes gravity and the universe on the biggest possible scale. And then, on the other side, you have quantum mechanics, the mind-bendingly successful theory of the super, super small. The thing is, they both work perfectly in their own realms. But the moment you try to put them together, they just fundamentally disagree. It's pretty much the biggest problem in physics. And the argument here is that the problem really goes all the way back to Einstein himself. In general relativity, you see, space-time and energy are treated as two distinct things. They were never actually unified into a single concept. And that right there might just be the original crack in the very foundation of modern physics. Okay, so how do we fix that crack? Well, this is where the idea gets kind of wild. What if, instead of trying to patch the crack, we've been looking at the whole building all wrong? For decades, the holy grail of physics has been this search for a theory of everything that can finally combine general relativity and quantum mechanics. But what if that's just the wrong goal? What if trying to stitch these two theories together is like, trying to sew two different shadows together to figure out what the object casting them looks like? Okay, so here's the big shift in thinking. General relativity and quantum mechanics, they aren't reality itself. They are simply human perspectives on reality. Think of them like maps. They are incredibly useful for getting around, for sure, but the map is not the actual territory. And just to be super clear, when we say perspective, we don't mean it like an opinion. We mean a human-made framework, a mathematical model we've built to make sense of what we observe. So general relativity is one lens we're looking through, and quantum mechanics is another. They let us see different aspects of the same, deeper reality. Now, the implication here is, well, it's huge. It means the ultimate goal of physics might not be to combine our theories at all. Instead, it should be to look past them, to try and discover the single underlying reality that actually gives rise to both of these perspectives in the first place. So, of course, that leads to the obvious next question. If our best theories are just different views of something, then what are they views of? What is the actual fundamental thing they're pointing towards? This is the big one, isn't it? If we could somehow push past our models and our equations, what would we actually find? Well, what's so cool about this new way of thinking is that it doesn't just ask the question. It actually proposes a really fascinating answer. And the answer is that reality isn't this collection of separate fields and forces and particles. No, instead, it's one single unified object. Everything we see, from a whole galaxy down to a tiny little quark, is just a different manifestation of this one fundamental thing. So how does that work? Well, the idea is that this one object is really a dynamic, changing 3D space. I want you to imagine space not as some static, empty box, but as a real substance that can move and stretch and compress. And when this substance curls up on itself in a specific way, in a really tiny local area, well, that's what we perceive as a particle. And bam! This elegantly solves that original problem we were talking about. Energy and matter are no longer these separate ingredients you have to mix together. They are simply features of this one dynamic space. This finally unifies space-time and energy, making them two sides of the same coin, which is exactly what Einstein was hoping for. So, does this mean we just throw out a century of physics? Do we abandon general relativity and quantum mechanics? No, not at all. The path forward from here is actually super pragmatic. We really have to remember, this isn't about tearing down our current theories. Those perspectives, as we called them, are incredibly powerful and predictive. They work. So the goal isn't to replace them, but to understand their limits and to see what might actually lie beyond them. And this is exactly why the effort to combine general relativity and quantum mechanics is still so valuable. Trying to merge them forces us to refine our perspectives. It forces us to make our maps more detailed and more accurate, even while we're also searching for the territory itself. So what this all leads to is a very practical two-track approach for physics. Track 1 is all about focusing on the foundation, searching for the properties of that single underlying reality. Track 2 is about continuing to refine our perspectives, making our existing theories like GR and QM even better. So, to put it simply, we need to search for the properties of changing space, while at the same time, we continue to refine our existing theories. And you know what? These two paths don't conflict at all. In fact, they support each other. The big takeaway here, then, is that we can, and we absolutely should, pursue both of these paths at once. It's really about making the search broader, a search for reality itself, and a search for better ways to describe it. And that just leaves us with a really fascinating final thought. For 100 years, the search has been for a new unified theory. But maybe, just maybe, what we're actually on the verge of discovering is a new reality altogether.